In this video, we're going to talk about slope-intercept form of equations, and we're going to start with a review of what slope is. So remember that slope, we use m to represent, and it is also the same as rate of change, which is the change in y over the change in x, or the rise over run. Remember that rise is your vertical or up and down change, and run is your left and right change, or your horizontal change. And in general, slope is a measure of steepness. So if we look at these examples, you can go between any 2 points, and points here have been marked, but really anywhere your graph is hitting at grid marks, you can put points in there and count between, and they don't have to be consecutive points. So we go up 2 to the right 1. So those, when you go up and to the right, those are both positive directions. So our slope here is 2 over 1, which can be simplified to 2. And it would work out the same if you go between another set of points. So if I went through these two, this would be going up 4 and to the right 2. So it would be 4 over 2, which of course reduces to 2 over 1. I always start furthest to the left on the graph and do my up or down first, because it helps me determine my the sign of my slope easier. So this graph is falling down, so I would expect my slope to be negative. This graph over here was going up from left to right, so I would expect my slope to be positive, which it was. So let's calculate it over here. So I'm going down 3 and then to the right 1. So my slope here, to the right 2, and my slope would be negative 3 over positive 2, or negative 3/2. Last one here, I'm going up 1 to the right 3. So those are both positive directions. So it would be positive 1 over positive 3, or 1 over 3, 1/3. So we use this when we're talking about slope-intercept form, and you have probably seen this before. We usually see this as y equals mx plus b, where m is the slope and b is the y-intercept. And so it is written as an ordered pair as 0, comma b, whatever that value is the y-intercept. One thing we want to take into consideration here is the slope is the coefficient of x. So it's the number in front of x. And b is the constant in the equation. And the reason I'm pointing this out is because if your equation is written y equals a number plus mx, b plus mx, so it's reversed, the slope is still going to be the coefficient of x. Like, this is still the slope, even though it's the second number that you see in your equation, and the b value is still the y-intercept. Here are a couple of examples to graph. We have y equals 2/3 x minus 1, and the coefficient of x is our slope. That's the number that is attached to x, so my slope is 2 over 3. The constant, what is not attached to x, is our b value, or our y-intercept of -1. So how that looks on a graph would be 0, comma, -1. And that is our starting point to graph. This is our starting point. And that is going to be on the y-axis. So x-axis, y-axis, and we would start by plotting that at -1, and then we would use our slope from that point and go up 2 to the right 3, up 2 to the right 3, and if you go down 2, you're going to go to the left 3, and that is because 2 negatives divide to a positive. So let's just note that right here. So a positive 2 over a positive 3 means that I'm going up 2 and right 3, but that is the same thing if I have negative 2 over negative 3 going down 2 and left 3. And that's going to fall on that same line. So we want to take a straight edge now and plot that line. So the graph of the equation y equals 2/3 x minus 1. We started at negative 1. We go up 2 over 3, up 2 over 3, and we get a positive line graphed just like this. Let's take a look at the next one. So here we have y equals 3 minus 4x. So when we're looking for the slope, remember we're looking for the coefficient in front of x. So my x is right here, so my slope is right here. We have to take the sign with it. So my slope is negative 4. And I'm going to write that as negative 4 over 1 because remember that negative 4 is equivalent to negative 4 divided by 1. Those are the same, but that helps me see my rise and my run. And then my b value is the constant. That is the part that is not attached to the x. So that's this 3. There's no sign in front of it. So my b value is just 3. And if I'm going to graph that as the y-intercept, it's going to be the point 0, 3. So again, let's label our x and y axes. And we're going to start right here at 3. And if that negative, if I'm thinking about it in the numerator or the top of my fraction, it's negative. So I'm going to go down 4 before going right 1 and plotting my point there. Down 4 more over 1, down 4 more. I usually plot to the end of my graph because it's easier to line up my straight edge. And if I go up 4, I'm going to go left 1. And the reason that is true is because this being negative 4 over 1, how I originally had it was down 4, and then the positive 1 is right 1. But negative 4 over 1 is equivalent to saying 4 over negative 1. So if my 4 is positive, that would be up 4, but then that makes my 1 negative, and that's why it is left 1. And then we're going to use a straight edge to connect our points. So the graph of 3 minus 4x, we start at 3, we go down 4 over 1, and it is this negative slope line that you see right here. Couple more quick examples here. So we're starting with this equation y equals x plus 1. Remember what the coefficient of x is if you don't see a number. Remember that is the same thing as 1, or if we're thinking about it as slope, we can think of that as 1 over 1. And then my constant right here for my b value is 1, so we're going to plot that as 0, 1. Label my x and y axes. So we are starting at 1 on the y-axis, and then we are going up 1 over 1, up 1 over 1. So we get this nice diagonal. If we go down 1, then it has to be the left 1, and it will fall in this line. I often will keep that pattern across my whole graph because it's easier to line up my straight edge. Take your straight edge and connect your points. I double check my line. It is rising as I go from left to right, which means it's a positive slope, which matches what I need to have. Taking a look at y equals negative 3x. I have x, so that means I have a coefficient of x. That's my slope. So negative 3 is my slope. I'm going to write that negative 3 over 1. So I have rise over run. Nothing is being added or subtracted here. You can imagine that there is a plus 0 here because adding 0 does not change the value, which means my b value is 0 and my starting point is 0, 0. It's the origin right here. Of course, we should label our x and y. And from that starting point, we're going to do our slope, and it is down 3 to the right 1. And we're going to keep going down 3 to the right 1 until we're off of our graph. If we are going up, because remember, negative 3 over 1 is exactly the same as 3 over negative 1. They're both negative 3. So I can go up 3 to the left 1, up 3 to the left 1 until I am at the edge of my graph. And then I can take my straight edge to graph it. And again, a quick double check. I am falling as I go from left to right on my graph. And so that means it's a negative slope. And I see that I should have a negative slope. Now we will talk about our special cases. Remember, we've talked about these before. So if I have an equation of y equals 1, that means the y value is going to be 1 everywhere along the line. So where is y1? If I label my axes, y is 1 right here. Y is 1 also over here. Y is 1 anywhere along that horizontal line. So I can graph a line through there, and we should use a straight edge. So this line right here is my y equals 1. If I'm looking at y equals negative 3, along my y-axis, y is negative 3 right here. Y is also negative 3 at this point. At this point, anywhere along this horizontal line, my y value is going to be negative 3. So y equals negative 3 is that horizontal line. And then y equals 6 along my y-axis. 6 is right here. And anywhere along that horizontal line, the y value is going to be 6. What I mean by that is if I pick this ordered pair right here, this point is 3, 6. This point right here is 0, 6. This point over here is going to be negative 7, 6 for our ordered pair. Everywhere along that line is going to have the y value of 6. So all lines that are of the form y equals a number, any number, will be horizontal. And we'll have a slope of, so think of what we're thinking about for slope. Remember, slope is rise over run. And if we look at a horizontal line, there is no rise. Like between these 2 points right there, there is no rise. But their run is whatever it is between any 2 points. So the rise is 0. And the run could be any number. And 0 divided by any number is going to come out to be 0. So it has a slope of 0. So all horizontal lines have a slope of 0. Now let's take a look at all lines that start x equals. So right here we have x equals 4. So remember our x-axis, our y-axis, where x is 4, we'll count over 4 to the right. And that point right there is 0, 4. Where else can x be 4 is going to be somewhere along this vertical line right here. All these points right here. This is 4, 0. This point right here is 4, 4. This point right here is 4, 6. If I pick a point down here, that's going to be 4, negative 3. The x value is always 4 for a vertical line. We want to use a straight edge when we're graphing. So this is my line of x equals 4. If I look at x equals negative 2, I'm going to go on my x-axis. I'm going to find where negative 2 is. That's right here. Anywhere along this vertical line, the x value will be negative 2. So that's the graph of the equation, x equals negative 2. And if I have x equals 0, that right here at the origin is where x is 0. And anywhere along the y-axis, the x value is 0. So x equals 0 is the same as the y-axis. All lines in the form of x equals some number so x equals any constant, any number, will be vertical and have a slope of, and let's calculate that. If it's, remember, slope is rise over run. And for a vertical line, rise is going to be any number. It depends on where you pick. So if I pick here, my rise is going to be 4. But it really doesn't matter. Whatever number you're calculating between your 2 points, it's going to have a rise. But the run, no matter what we're talking about, it doesn't go left or right at all along a vertical line. So the run is always going to be 0. And you know that if you have any number divided by 0, it's going to come out to be undefined. If you put that in your calculator, for example, if you do 2 divided by 0 or 5 divided by 0 or negative 100 divided by 0, it's going to come out to be undefined. So the slope of all vertical lines is undefined.